Okay, we'll begin, yeah. I hope you can see the screen, right? The presentation that I just shared. Anyone can confirm if you can see the screen. Okay, anyway, so good evening and welcome to today's session. So today's lecture shall be on municipal solid waste management. So it's a pretty interesting topic actually, and it's something that we all require. And while I was preparing the slides for this week's lecture, I was thinking of, let's say, Sweden or some place actually where they have achieved zero MSW. Like they're utilizing MSW very effectively. Okay, and in some cases they are in fact importing waste because they're turning waste into energy and all that. But then I remembered just this morning that there is a case in India also where uh, uh, that has been done actually. Okay, so I'll just tell you where that is, and yeah, first let's go over the contents, right? So discussion of answers from the previous week. Okay, we start with that. Then what is MSW and what are its constituents? That is the second topic. The environmental hazards of MSW, and then municipal solid waste management practices, advantages of primary segregation, waste to energy technologies, and then I'll be covering one case study and one actual case, like I was just mentioning, right? The case study is on the environmental assessment of MSW management approaches. So that is for Dhanbad in Jharkhand, and the Swachhbharat mission and the success of Indore. So in Indore, this has actually been done, and it's been a huge success model. And many of you might know that Indore has constantly backed the top position in the Swachh Bharat rankings. Okay, so we'll see what they have done. All right, and then we'll go on to the questions for this week. Okay, so from last week, let's have a look at the question and answers, right? So what are the three levels of energy use? That was a question. So there are three levels. The first is basic level, which is the consumption of energy for basic necessities like cooking and lighting. And the second level is social use, that is consumption of energy for the larger community. Okay, so you could have parks or schools or clinics or street lighting and so on. And then the third level is productive consumption of energy, that includes consumption for providing goods and services. That is, you could have some micro, small or medium enterprises, some cottage industries, or even agriculture. Okay, because they are also producing value, right? They're producing something of value for the economy, right? And generating local employment. So the answer is here, the basic, social and productive. Okay, the second question was the main goal of the Energy Plus program, right? So what is the Energy Plus program? So first, connections have to be provided. Okay, so from levels of we need to go to levels of aspiration from being devoid of it, right? Devoid of electricity or being devoid of let's say LPG connections. So first we have to provide these connections, then we have to provide these connections or energy for productive use, energy for lifestyle use, okay, and social uses. And the third level is the Energy Plus, that includes energy plus empowerment. Okay, so that includes energy access with empowerment and providing connections. Yeah, so basic and social access, and and then productive use, that means employment and income generation. Okay, so the goal of this program is to empower the poor by providing access to modern energy services. So this is the answer, right? Number 3, what are the benefits of switching to modern cooking stoves from the traditional firewood stoves? Okay, so traditional firewood stoves, they use firewood, right? So they need to be procured from the forests or some plantations or so. So mostly people have to walk a long distance to find this firewood, and then they have to carry it back. Okay, and burning this firewood releases pollutants such as carbon monoxide, nitrogen oxides, SO2, particulate matter. So all of this causes indoor pollution, and it causes health, like respiratory diseases and so on. Okay, but on the other hand, modern stoves are equipped with gas cylinders which are easy to replace. All right, so you can just go to the gas agency, and then get a replacement cylinder. Okay, so they eliminate the modern stoves eliminate harmful indoor emissions. Okay, they have better heat transfer metrics, and they are more efficient. Okay, and they are more convenient in terms of refueling. So the answer is all of the above. Question 4 was, categorize the following as per the levels of energy use. The first is electricity consumption at a local clinic. So local clinic is something that is social, right? It's for the community. Okay, home lighting, it's a basic requirement. Okay, it is required no matter what, so it is a basic requirement. Third is electricity consumption in a small scale factory. So that is productive use, because they are producing something of value for the economy, and they are creating employment. So the answer is the first one. This is social. The local clinic is social. Then you have home lighting, that is basic, and small scale factory, that is productive. Number 5 was, what is the purpose of normalization of indicators? Okay, so you have many indicators even within the same dimensions that are not the same unit. They have different units. Okay, for instance, if you compare let's say within the environmental dimension, let's say the global warming potential and the acidification potential. The global warming potential is measured in kg of CO2 equivalent, and the acidification potential is measured in terms of kg of SO2 equivalent. So right there is a change of unit, right? So you cannot compare them on an absolute basis. So what you have to do is, you have to standardize them with respect to some threshold value, like the best and the worst values, and so you obtain a score between 0 and 1. Okay, so that is what normalization is. So you standardize them, and then you can compare it. Okay, if greenhouse gas or global warming potential is, let's say, 0.8, that means that's very good, and acidification is only 0.4, so that's the system is emitting a lot of NOx or NH3 or something. So you can conclude that. So the answer is to standardize the indicators with different units for easy comparison and aggregation. Okay. Next, which among the following are social indicators of the electricity system? So the first one is share of coal in the total electricity generation. So so if we measure this, that would give us an idea about the greenhouse gas and other emissions from the system. Okay. So and similarly, the sulfur dioxide emission, that is a measure of acidification. Okay, acidification potential, and both of them are environmental indicators. Okay, and transmission and distribution losses, they lead to lower efficiency of the system, and hence increase the cost of electricity production. Okay, or electricity delivery basically. Okay, so that's a techno-economic indicator. Okay, but when we talk about the reliability of electricity supply, that measures parameters like voltage of supply, the frequency of supply, and the availability of electricity in each day, like how many power cuts you have and so on. Okay, so this is a social indicator. So if you depend on electricity for your work, let's say if you're studying, or if you have a factory and you want to produce something, if the electricity is unreliable, obviously it is hindering your progress. Okay, so this is a social indicator. Okay, number 7 is the lack of access to reliable energy supply. Okay, so that is called energy policy poverty. Okay, productive energy services we have just seen. So when energy is produced for productive use, like industries and so on. Social energy service, again, it's if it is for community use, like street lighting or parks and so on. And energy connectivity is the exact opposite of this energy poverty. Okay, the answer is this. Okay, according to the UNDP, the threshold limit is set to 10% of the household income. Okay, as the energy poverty line. So you have an economic poverty line, right? So if you earn so many rupees per day or something, I think most recently it was 32, something like that. I don't remember. So this is the energy poverty line. So it's set to 10% of the household income. And the next one is which of the following are energy service companies? So an energy service company is any enterprise that provides some form of access to energy and associated end-use services. Okay, so if a company builds biogas plants, obviously they are going to supply biogas, and that's an energy plant, right? A biogas plant is an energy plant. Okay. Similarly, a company that manufactures wind turbine blades is aiding in the integration of renewable energy in the grid. So that is again an energy service company. Okay, and an electricity distribution company provides electricity to households, communities, and industries. Okay, so this is also an energy service company. So the answer is all of these. All of the above are energy service companies. Okay, so do we have any questions, any doubts in the previous week's lecture, or can we proceed to this week's? Anyone? Okay, so let's go into today's lecture. All right, so municipal solid waste management. Okay, so what is municipal solid waste in the first place? Okay, so it is the waste that is resulting from any community or any city or any commercial establishment or an institution or some recreational activities. So basically any community is there, right? Any large community, the solid waste that this community produces is called can be classified as municipal solid waste. Okay, so normally we have like towns and cities and so on, but villages are not usually classified under this because the waste produced by villages are not to that level, right? So cities and towns are usually classified under MSW. Okay, so how can they be classified, right? There are different categories of municipal solid waste. So first is compostable, that is biodegradable. So you have your organic kitchen and garden waste. Okay, so you have your vegetable peels, your fruit waste and so on. Okay, Garden waste include like you have your dead leaves and all that, so they are all compostable. That means that they can uh, through a biochemical process they can be composted. That is you can produce organic manure from it, and that can be given to farmers or some gardens and so on, or you can use it again in your garden to grow your plants and vegetables, fruits, whatever you want. Okay. The second is recyclables. Okay. So what can you recycle? So you can recycle paper, plastic, glass, and so on. So these all come under recyclables. Then you have hazardous or toxic waste. You have pesticides and medical waste. Okay. So if there is a used injection or let's say some medical procedure is happening, okay, let's say surgery is performed using a knife or something, that knife cannot be reused on another patient, right? It has to be properly treated, and so it comes under medical waste. Okay. And then you have your inert inert means something that does not react, or something that does not um, that does not cause any harm, basically any inorganic material, like you have stones, sand, and all that is mixed into the municipal solid waste. So these do not cause any harm or do not react with any other substance. So these are inert substances. Okay. So in India we are producing more than 62 million tons of waste per year. Okay. And out of this only 82% is collected. Okay. So 18% of this, okay, is not collected even. I mean, it's just lying in some dump, in some unorganized dump actually. Okay. And out of this 82% that is collected, only 28% is subject to treatment, and the rest ends up in landfills. Okay. So there will be some designated landfills outside the city where you just dump them. Okay. So obviously this is not a very sound management practice, so that's what we'll be discussing in the further slides. Okay. So in India we have almost half of our wastes are biodegradable. Okay. And paper is about 7%, plastic about 10%, and there are other wastes which are about 32%. This is out of this 62 million tons that we are generating each year. So what are the environmental hazards of municipal solid waste? Okay. So we have water pollution that occurs due to heavy metals. Okay, heavy metals like arsenic, you have some lead, arsenic, all of these are heavy metals. Okay. And if they are discharged into water, they cause pollution. Okay. And if we cannot ingest them, it's slow poison. Okay. So if we ingest heavy metals, then we will be subject to a lot of health issues. Okay. And it's also caused due to fluorine ions or nitrate ions and so on. Soil pollution, again due to heavy metals, fluorine ion, nitrate ions, and so on. Okay. Then air pollution is caused due to carbon monoxide, nitrogen oxides, sulfur dioxide, particulate matter, hydrocarbons, total hydrocarbons, and so on. Okay. This occurs due to burning of these wastes. So sometimes you just burn. In certain states, it's the norm to actually burn the dry waste. So that's a very bad practice actually environmentally, because of this reason. Okay, because they are emitting so many pollutants, right? And then there can also be biological pollution because of fungi, bacteria, and viruses that are present in the biodegradable section of the MSW, right? So when we talk about open dumping, so you would have seen some dump sites. Okay, so there will be many places in the city where unauthorized dumping will take place. and the municipal corporation may not do anything about it, and it would have been there for like years and years, okay, and it's just there, right? No one is doing anything about that. And then there is also unsanitary landfilling. What does this mean? Unsanitary landfilling is basically when you don't segregate your waste, okay, and these landfills are designated by the government, okay, maybe some place outside the city where you just dump everything. Even though it is designated, it's not a sound management practice, because you've not um, segregated any of the waste. So you are mixing your biodegradable waste with your inorganics and your hazardous waste, everything. So it may lead to leachate. Leachate is formed by the biodegradable uh, portion of the waste, right? So if leachate runoff happens, that causes soil and water pollution, as you can see here, okay. So this is normally caused only when there is runoff, right? So when it goes into water bodies or into seeps into soil, so that causes soil and water pollution, okay. And air pollution also occurs because of anaerobic digestion. So how anaerobic digestion takes place? See, you have the biodegradable part, okay, and there are microorganisms present in that landfill, right? So because of that, they release some methane, carbon dioxide, and ammonia. All right. So that causes air pollution and global warming also. As you know, carbon dioxide and methane, they are very potent greenhouse gases. And open burning, like I just said, they cause carbon monoxide, CO2, particulate matter, NOx, and SO2. Okay, and unsafe handling by workers. Okay, workers who are working with, disposing of the garbage. And there are unauthorized agents also. So you can see the rack pickers and so on that you would have noticed, right? So they scavenge these garbages for some metal pieces that they can recycle or sell, okay. But they do not have any proper protective equipment like gloves or mask, or they don't have anything. So that's very dangerous, and it will cause some health hazards like gastrointestinal disorders, skin diseases, respiratory diseases, cholera also, because cholera is waterborne, right? And and cardiovascular diseases. So how does what happens to the garbage once it's taken, right? Once it's produced in your home. So the first part is collection, okay. The government or some agency has to collect the garbage from your house or from a community. So it could be either door to door collection or community collection. So door to door is when they just come to each house and then they collect, or community means they you may have to just bring your garbage to some place and dump it, and then from there they'll collect it, okay. The second portion is segregation. So either before you give it off to the agency, you can segregate it at source, that is in your house only. You can segregate it, the dry waste and the wet waste, okay. So because if you don't segregate it, what they have to do is after collection they have to segregate using they have to employ manpower for that, or they may use some machines and so on, okay. So there are two types of segregation. So primary, which is at source, and secondary is after collection. So naturally if you segregate after collection, it is more resource intensive and more energy intensive. So we have to try and avoid this as much as possible. The third is transportation of these waste. So from the collection point, wherever they are collecting, to the processing unit. In fact, processing units, because if we are segregating it, the dry waste goes to another some processing unit. The wet waste may go for composting or for biogas production and so on. The fourth is processing, so treatment of hazardous waste or chemical waste and so on, or waste to energy. So you can produce biogas, you can produce ethanol also. In fact, you can ferment the biodegradable part and produce ethanol, and the dry waste is sent for recycling. Okay, the paper, the plastic, glass and so on. Then the final is disposal. Now disposal can be done either by burning the combustible part or burial in landfills. Normally, if you are doing burial in landfills, what you have to do is you have to ensure that only inerts are present. So you have to remove everything else and then process them, maybe use them again or something. If there are only inert like stones or let's say sand or something, then this won't be an unsanitary landfill anymore. Okay, because if you have something else, like if you have biodegradable mixed with non-biodegradable and then you're dumping that, then that becomes a breeding ground for diseases. So what are the advantages of primary segregation? So as I had just told you, primary segregation is segregation at source. Okay, so it reduces the need for secondary segregation, which is capital and resource intensive, because this segregation essentially, if you segregate at home, you won't need excess manpower or excess machinery to segregate it after collection. Okay, so waste segregated at source are not contaminated with other types of waste, so they are easily recyclable or treatable. Now when it goes for secondary segregation, right, so you have not segregated at home, so they have collected it, now they are going for secondary segregation. What happens is, now it is already mixed, the waste is already mixed, it is a little hard to segregate at this time. But even if they do, they cannot do 100%, because it will always be contaminated with other types also. If there is a plastic, there is polythene, so how much ever you clean it, there will be some biodegradable part in it, right? So you should avoid that. Okay, and another important point is that it reduces the quantum of waste to be transported and treated. Why? Because you can use some decentralized waste management measures like composting units. Like if you see in big cities, like I know in Bangalore, there are many apartment complexes that do this. Okay, so we are segregating the waste here. The dry waste will be taken by BBMP, which is the municipal corporation, and then the wet waste, the biodegradable waste, goes to the composting, which is present within the the apartment complex itself. So yeah, we compost it and then we send it off to somewhere where whoever needs it or something, so we can even sell it. Okay, so because of that, the quantum of waste reduces, right? So you only have to transport the dry waste, which becomes easier, so the transportation costs are also lower. Okay, and because of the segregation, it leads to lower emissions of landfill gas, because the biodegradable part is no longer there in the landfills, right? So the landfill gas will also be lower, and that leads to lower lower carbon emissions, CH4 emissions, and lower pollutant emissions, right? So these are some of the waste to energy technologies. So you have the organic portion of municipal solid waste, that is the waste that contain carbon. So that's what I mean by organic here. Okay, so they can be subject to either thermochemical or biochemical conversion. So in thermochemical, you have incineration. So only the combustible part of the MSW, it's called refuse derived fuel. I'll just explained that in one of the questions. Actually, I've written that. I have not written it here. RDF. Okay, that can be subject to thermochemical conversion. So there are three ways you can do it. So incineration, gasification, or pyrolysis. So incineration is nothing but combustion. Okay, so you obtain power and heat from it. And if you do gasification, you can obtain power, that is through syngas. You produce syngas, and from syngas you can either generate power, or you can convert it into hydrogen, methanol, ethanol, and so on. So biofuels you can produce. Pyrolysis will produce bio oil, which can be converted into biodiesel, and it also produces biochar. Okay, that is charcoal, which can be used for, let's say, water treatment, water filtering basically. Okay, and on the other side, the biodegradable part can be subject to anaerobic digestion, all right, or composting, or fermentation. So anaerobic digestion will produce biogas, which is a mixture of methane and carbon dioxide. So you separate out the carbon dioxide, now you have pure methane, which is nothing but natural gas, right? So you can pump it into the natural gas pipeline itself. So you can have a blend of natural gas, the fossil natural gas, and biogas. Okay, or you can do composting like I just explained, and you produce organic fertilizers, or you can do fermentation to produce bioethanol. All right, so we come to the case study, the first case study. So in 2018 there was a study carried out on the environmental assessment of municipal solid waste management scenarios. So they this study they have done it for Dhanbad, which is in Jharkhand. Okay, and so they evaluate 4 scenarios. The first scenario is collection of the waste and transportation. Second scenario is baseline, the baseline scenario, that is what is being done right now in Dhanbad. Okay, they've taken it as it is. So that includes open burning of municipal solid waste, unsanitary landfilling, and open dumping, like unauthorized dumping. Okay. Third scenario is they have included a hypothetical scenario where they include composting and landfilling. Okay, and the fourth scenario is recycling. They've included recycling also, composting and landfilling without energy recovery. Okay, they are not doing any waste to energy here. They are only doing all of these, like recycling, composting, and landfilling. Okay, so the life cycle impact assessment was carried out using CML2 baseline. Okay, so this is a database to quantify the impacts, the environmental impacts. Okay, 11 impact categories. So there are many, like abiotic depletion, ozone layer depletion, human toxicity, let's say photochemical oxidation potential, acidification potential, eutrophication, global warming potential, and so on. Okay, and what they concluded is that the baseline scenario, that is when you do open burning, unsanitary landfilling, and open dumping, that is what is happening right now in Dhanbad, it leads to the most impact, okay, in terms of global warming, in terms of photochemical oxidation, eutrophication, human toxicity. Whereas scenario 4, where they are considering recycling of the waste, composting of the biodegradable part, and landfilling the innards, that has the best best environmental results. Like I said, it does not consider the energy recovery from the landfills. This I have already discussed. The first scenario was the collection and transportation, which includes the existing MSW collection and transportation with a 73.5% collection efficiency. So this means that only 73% of 73.5% of the waste that is generated every day is collected. Okay, the rest, what, 27% is just, I mean, it's lying in open dumps, or no one knows what happens to it, right? The second is baseline scenario, which considers the waste management practices currently adopted, okay, which was, as I had just told you, the open burning, unsanitary landfilling, and open dumping. Okay. Scenario 3 is they have included composting and landfilling without energy recovery. Okay, that is converting the open landfills and unsanitary landfills into sanitary landfills because of segregation. So you segregate it and then you make the unsanitary landfills into sanitary landfills. And scenario 4 is recycling, composting, and landfilling without energy recovery. So recycling of paper, plastics, and e-waste and so on, and composting of biodegradable waste, and landfilling of inert waste. Okay, so Dhanbad produces around 147 tons of waste per day. All right. So out of this, compostable is, that is biodegradable, is 37%, recyclable is 26%, and inert is 31%. So how they are managing it? Most of it is unsanitary landfilling. So you can see they are not segregating any of it. Okay, it all ends in some landfill outside the city. 74%, 3/4 of it, and the other 23%, there are like 23% that ends up in open dumping. So which is no better than unsanitary landfilling, or even worse in fact. And 1% is open burning, which is even worse because it leads to pollution. And only 2% is recycled, but that is also not organized. You know, the, like I said, the unauthorized agents who are scavenging these wastes for some kind of metals that they can recycle, right? So they are the ones who are inadvertently doing the recycling. Otherwise, even this wouldn't have happened. Okay, so the waste management practices are very bad right now, right? So you can see the results. So remember that S2 is the baseline scenario, that is what is happening now. Okay, so this is the global warming potential, acidification, ozone depletion, and eutrophication. So you can see that the global warming potential is very high in the current scenario because of unsanitary landfilling and open dumping, open burning, and so on. And S4, that is with recycling and composting, so they, it has the lowest impact. All right. And similarly for acidification potential, okay, the S2 has the most impact and S4 has the least impact. And over here, this is the ozone depletion potential. This has low impact. In the current scenario, it has low impact and higher impact because of chlorofluorocarbons actually. Okay, because when you are doing certain management, MSW management, right? So you may have some emission of chlorofluorocarbons that is causing this ozone depletion, right? And eutrophication also, you can see that the baseline scenario has higher impact than the other two scenarios, that is S3 and S4. Okay, now we'll talk about the Swachh Bharat mission and how Indore has turned into a success story. Okay, this is very interesting. Like I said, I just came across this paper and what they have done, right? So Indore is producing around 1,000 tons per day. Okay, and they have classified their waste producers into 3 different categories: domestic, semi-bulk, and bulk. So domestic is 25, semi-bulk is 25 to 100, and bulk is 100, more than 100 kg per day. And so this is inert, right? Ash is inert, so 45% is inert waste. Compostable is around 40%, and this is also inert. Stones 20%, and there are some recyclables, around 13-14% of recyclables, and there are metals also, less than 1%. So what they are doing, I'll just explain to you. So what they have done is, they have used print media, electronic media. Not only that, religious and cultural festivals like Ganesh Chaturthi, we have Ganesh Pandals and all, no? So Dashara, Gandhi Jayanti, all of these, they have used these mediums to propagate, to create awareness among the people, for the importance of primary segregation. That is the segregation of the waste at source. Okay, and they have done some door-to-door collection for the domestic generators, and bulk collection for the semi-bulk and bulk generators. Okay, and they have analyzed the waste generated per day in each ward, and then created a detailed route plan for the waste collection, like for the garbage trucks, right? So they have created a detailed route plan, and each of these trucks are fitted with GPS, so the drivers cannot deviate from this route. If they are deviating, then they'll be reprimanded for that. Okay, so they have done that. And this garbage collection truck, they have 3 separate compartments in the same truck for dry, wet and hazardous, dry, wet and hazardous waste. Okay, and they are given personal protective equipment such as masks, gloves and so on. Okay, and there is Aadhaar linked biometric attendance for these workers, and an app based resolution of complaints for the citizens. So if certain in certain areas garbage has not been collected or something, there is an app called 311. So I've never tried it. It's I have not checked it out, but there is an app called 311 where you can complain, and then the complaint will be resolved immediately, like where there is a quick resolution of complaints. And another thing that they have done is they have relocated the stray cattle to outside the cities. They've built some shelters and all that. Okay, so for the transfer of waste, okay, they've built decentralized garbage transfer stations. Earlier it was centralized, now they have built some decentralized stations, and some of these, they generate their own electricity from biogas that they produce using the waste that they receive, and they've installed some solar PV modules. So there is complete self-reliance over here. So this is available, I think, in only one of these garbage transfer stations, but it can be scaled up, right? It can be used for the other transfer stations also. So these segregated waste are compressed and sent for further processing. So the wet waste are sent to the centralized composting unit, and dry waste are sent to the material recovery facility. So what happens in material recovery? So first, pre-sorting is done using a trommel machine. Okay, so to remove inerts from recyclable waste. Then the segregation of these recyclable waste is done. That is, you have your paper, your plastic and your glass and so on. So you need to segregate that also, right? So the people would have segregated biodegradable with non-biodegradable, that is dry and wet waste. But further segregation has to be done. So that is done manually using kabadiwalas, the registered recyclers. Okay, and what they are doing is they are recycling. They are actually creating briquettes out of these polythene bags. They are cleaned and briquetted, and then they are sold to pipe manufacturers. So they are using these pipe manufacturers, the irrigation pipe manufacturers. What they are doing is they are using the waste plastic, right? Recycled plastic basically to manufacture the pipes. Okay, and the other recyclables are cleaned, and then they are sold to wholesalers like plastic and other plastics and paper and so on. They are sold to wholesalers for a profit. So that profit goes again into managing this entire system, right? So they've created a very efficient system, and another very interesting point is that they have certain biogas and organic manure plants. Okay, there is a 20 tons per day biogas plant. It produces 20 tons of biogas per day. Okay, and it is situated near a fruit and vegetables market, so the feedstock is right there. So the fruit and vegetable waste, they come to this plant and then it's converted into biogas. Using that, they are operating 15 buses, all right, each day to run more than 2000 kilometers. This is happening each day. Okay, can you imagine the scale, right? So this is a huge success story, because of which Indore is currently bagging the top rank in Swachh Bharat rankings. Okay, and yeah, so we're at the end of today's lectures. We'll go into the questions shortly. You please let me know in case you want me to do something again, or shall we go into the questions? I hope you understood what I spoke about. Are there any doubts? Okay, I wanted to ask, if is there anyone from Indore over here in today's class? No one? Okay, that's fine. If there was someone, then I would have asked them to give even more inputs as to what's happening there, because I retrieved all this from a paper, actually from a review paper. Okay, and in fact there is a lot more to it than what I have just shown in these two slides. You can you can go to this one second. So you can just check out this, right? It's called Municipal Solid Waste Management of Indore, a review. Okay, and it's published in this journal, right? So you can just check it out. You do a Google search, I think you should be able to get it. Okay, please go through it. It's very interesting on what they have done, and this has to be emulated by all cities, I feel. Okay, because the municipal solid wastes are such a huge nuisance, I should say, for any big city, and we all should emulate that. And to think that we don't even have to go out of the country for such examples. So such examples are there within our country itself, and so we need to replicate that model elsewhere also. All right. Anyway, let's go into the questions. First, the term municipal solid waste denotes A, excess nutrient runoff from agricultural fields, B, effluents produced as byproducts in a factory, C, wastewater produced by industries, or D, solid waste produced from cities or communities. Yes. Any more answers? Absolutely. Okay. Question 2. Which among the following are compostable waste? A, used injections, B, waste paper, C, banana peel, or D, stones? Yes. We have more answers. Go to this question again. Compostable waste, okay, that can be composted. A is used injection, B is waste paper, C banana peel, or D stones. Yeah, absolutely. Okay. Next is, which of the following statements are true? A. Unsafe handling of unsanitary landfill sites causes health problems. B. Open dumping of unsegregated waste leads to global warming. C. Organic portion of the MSW in landfills causes air pollution. Or D. All of the above. Okay, I'll go through the question again. Your first option is unsafe handling of unsanitary landfill sites causes health problems. B is open dumping of unsegregated waste leads to global warming. C, organic portion of the MSW in landfills causes air pollution. Or D, all of the above. More answers? D or C? Can you be specific? You can go through the question again. See, first is unsafe handling of unsanitary landfill sites. Obviously, like if you don't use gloves or these unauthorized people who are going to landfills to scavenge for metals and so on, they are not using any gloves or any protective equipment. They are prone to more diseases like skin diseases and respiratory problems and so on. These open dumping leads to global warming. So open dumping, what happens without segregation? It is mixing of the biodegradable and non-biodegradable degradable, right? So anaerobic digestion happens. The landfill gas or the methane, right, that is spread into the atmosphere. Okay, that causes global warming. And C is organic portion of the MSW causes air pollution. So methane does not cause air pollution. The same thing, this same anaerobic degradation happens, but it causes the emission of ammonia, and sometimes it may cause NOx emissions also. Okay, so that is what causes air pollution there. All right. Yeah. Next is identify the true statements. A. Secondary segregation is better than primary segregation in terms of cost and resource efficiency. B. Waste segregation at source is called primary segregation. C. Waste such as paper and plastics are compostable. Or D. Unsegregated waste in landfill are sustainable. I'll go through it again. A. Secondary segregation is better than primary segregation in terms of cost and resource efficiency. B. Waste segregation at source is called primary segregation. C. Waste such as paper and plastics are compostable. Or D. Unsegregated waste in landfills are sustainable. Yeah, absolutely right. So the other three, primary segregation is any day better than secondary segregation. There are no two ways about it. And paper and plastics are, what are these? Can someone tell me? If they are not compostable, can you tell me? Paper and plastics are not compostable, so what are they classified as? Anyone? Are they hazardous or are they inert? They are not compostable, so there is one more category. No one? Okay, I'll just tell you, they are non-biodegradable, yeah, but see, even your stones and all are non-biodegradable, right? So these are recyclable materials. So stones and all, they are not recyclable, they are called inerts, okay, because they don't react with anything else and they don't cause any harm. Like I said, paper and plastics can be they can be recycled, okay. And unsegregated waste in landfills, they are not sustainable at all, and because they cause health problems, they cause pollution, they cause a lot of problems actually. Okay, I was talking about refuse derived fuels a few slides back, right? So refuse derived fuel, RDF, is a combustible fuel produced through extracting and processing the combustible part of MSW. So please understand this statement. So it is a combustible fuel, so you can burn it, okay. So it is produced through extracting and processing the combustible part. So paper, plastics, all of these are combustible. So you extract that, you process that, and then you make them into pellets or something, okay. So that is refuse derived fuel. So through which method the energy in this fuel can be extracted, okay. So your options are A, incineration, B, hydrolysis followed by fermentation, C, anaerobic digestion, or D, transesterification. Anyone? So RDF is basically a combustible fuel, okay. You can burn it, but what we are doing is we are segregating it from the biodegradable part. You're taking only the part that can burn, okay. You're processing it, making it into pellets or some shape, right? So it can be easy to burn, okay. So these are combustible substances basically. So which method can be used, okay? Anyone? Yes, absolutely. Yeah. So because hydrolysis and fermentation is biochemical, anaerobic is also biochemical, transesterification is a chemical process to convert bio oil to biodiesel. All right. So incineration. So incineration is basically combustion. So you can convert it into power. You will obtain heat, and then you can convert that heat into power, or you can use the heat directly. Number 6. Which among the following are sound MSW management practices? A, landfill gas recovery, okay. That is the gas that is produced, the methane and other gases, right, because of the anaerobic digestion that's happening in landfill. So you recover that. Or B, in situ composting of organic waste. C, extracting and converting combustible recyclables into RDF, refuse derived fuel. Or D, all of the above. Yes, absolutely. But you need to understand one thing. See, this assumes that there is an unsanitary landfill, and then some gas is generated there, and then you are recovering it. It is a sound practice, of course, but you need to avoid the unsanitary landfill in the first place. Okay, so that needs to be kept in mind. So, uh, so it's more like when we say prevention is better than cure, right? So this landfill gas recovery is a cure, okay, and these are preventions, okay. So even though they are all treatment to the same disease, it's like this is cure and this is prevention. So that needs to be kept in mind. What is meant by collection efficiency? Okay, A, the percentage of collected MSW that is segregated. B, the percentage of segregated MSW that is composted. C, the percentage of recycling of the recyclable portion of the MSW. Or D, the percentage of the overall municipal solid waste collected through proper channels for further processing. Okay, so I'll just read the options again. Percentage of collected MSW that is segregated. Okay, the second is what portion of the segregated MSW is composted. Third is what portion of the recyclable portion is sent for recycling. Or D, how much MSW is collected out of the total produced, right? Yeah. Anyone else? Yes, absolutely. Okay. Number 8, why is burning of municipal solid waste without energy recovery a bad management practice? A, it causes global warming and air pollution. B, it may lead to acidification. C, it causes depletion of fossil fuels. Or D, both A and B. Absolutely, because global warming is through carbon dioxide, air pollution is through carbon monoxide, NOx, and so on. Acidification, because NOx also creates acidification. There is sulfur dioxide, everything, though those lead to acidification. All right, depletion of fossil fuels, not much. Okay, at least not directly. All right, so it's both A and B. All right, so that's it for today. Okay, so do you have any doubts? Exam will be MCQ. Okay, it won't be a subjective type, it's MCQ. All right, any other doubts? Okay, thank you for joining. Okay, I'll see you all next week, same time around 6 o'clock. Okay, and have a great weekend. Yeah, right, thank you.